Ever wish you could just talk to your devices
Yeah.
and they do exactly what you want?
Absolutely.
Like open apps, book flights,
Uh-huh.
even play that perfect song all without lifting a finger.
Yeah,
Well, that's the future that LLM-brained GUI agents are building.
it is.
And it's closer than you might think.
Definitely closer than we think.
We're taking a deep dive today
Okay.
into how AI is learning to navigate the visual world,
Uh-huh.
just like we do,
Right.
using graphical user interfaces.
Sure.
We've got research papers and technical articles stacked high, ready to break it all down.
Awesome.
So if you're curious about the tech that could change
Yeah.
how we interact with everything digital,
I am.
this deep dive is for you.
What's fascinating is that the very thing that made computers easy for us to use,
Yeah.
those graphical interfaces with buttons and icons and all that,
Right.
has been a roadblock
Yeah.
for traditional automation.
Yeah. It's like we speak different languages, right?
Exactly.
We point and click,
Yeah.
while computers need precise code.
It's true.
It's like a totally different way of interacting.
But LLM-brained agents are changing the game.
Okay.
These agents can process language, learn from examples, and actually make decisions
Wow.
based on what they see on the screen.
Okay, so before we go full sci-fi, let's
So-
rewind a bit.
Okay.
How did we get from clunky old automation scripts to these AI agents that seem almost magical?
It's been a journey.
Yeah.
Steps.
Okay.
Each building on the last.
Okay.
Early on, it was all about writing scripts for every single
Oh, okay.
click and keystroke. Imagine the tedium.
Yeah. No thanks.
Then came systems that let you give basic commands like click the button that says submit.
Okay.
Helpful, but still limited.
So the real leap was combining the power of LLMs with computer vision.
Precisely.
Okay.
That's when we started seeing agents that
Yeah.
could handle more complex tasks.
Uh-huh.
Things like AutoDroid for your phone
Okay.
and UFO for desktop environments.
So let's peek inside the brain of these LLM-powered agents.
Okay.
What makes them tick?
Imagine an AI looking at your screen, just as you are right now. What does it need to understand to carry out a task?
Well, first it has to know where it is, right?
Yeah.
Is it on a website, a mobile app, or something else entirely?
Exactly. The operating environment is key.
Okay.
It's like giving the agent a map of the digital terrain.
And just like a map has mountains and rivers,
Yeah,
each platform has its quirks.
absolutely.
Okay.
Web apps use HTML. Mobile apps have touch gestures.
Right.
And desktops have their own set of programs.
Gotcha.
The agent needs to know the local language, so to speak.
Okay, so it knows where it is,
Right.
but how does it actually see what's on the screen?
But this is where it gets really cool.
Okay.
The agent uses a few tricks. Taking screenshots, analyzing the structure of the interface,
Right.
and even reading the text
Yeah.
on those buttons and menus.
Wow.
It's like giving the AI a set of digital eyes.
I read that some researchers have even trained models to identify interface elements even when the layout changes.
It's amazing.
That's wild.
Computer vision is a game changer here.
Yeah.
It's like the agent can now understand the visual language of any software,
Ah.
even if it's never seen it before.
So the agent knows where it is
Right.
and can see what's there,
Yep.
but how does it know what we want it to do?
That's the art of prompt engineering.
Okay.
We need to translate our human requests into instructions that the LLM can understand. Think of it like giving someone really clear directions
Okay.
with landmarks and specific detail.
So if I wanted the agent to say, book a flight for me, I need to be very specific about the dates,
Right.
destination, and all that.
The more specific, the better.
Okay.
Remember, these LLMs are great at learning from context,
Right.
so even giving them examples of successful bookings
Okay.
can help them get it right.
Okay. The prompt is set.
Right.
The AI has its marching orders.
Yep.
What happens next? This is where the real thinking starts, right?
This is the model inference stage.
Okay.
The LLM takes the prompt and the information it's gathered about the interface and starts to formulate a plan.
Okay.
It's like the AI is coming up with a strategy
Right.
to achieve the goal you've set.
So it's not just blindly following a script.
Right.
It's actually reasoning
Yeah.
about the best way to get things done.
Exactly.
That's impressive.
And this is where we see the difference
That's
between a general LLM and one that's specifically trained for GUI tasks.
It's like the difference between a general doctor and a specialist, right?
Exactly.
One has broad knowledge, while the other is a pro in a particular area.
And when it comes to complex GUI interactions, having that specialized knowledge makes a big difference in how fast and accurately the agent can work.
So the AI has a plan.
Right.
It knows what to do.
It does.
Now it's time to actually act.
Okay.
What does that look like?
This is where the agent translates the LLM's instructions into concrete actions.
Okay.
It might click buttons, type text, swipe on a screen, whatever it needs to do to carry out the plan within that specific environment.
And this is where having the right toolkit is important, right?
Absolutely.
Like if the AI is playing a game, it needs to know how to use a controller.
Yeah.
And if it's in a word processor, it needs to understand keyboard shortcuts.
Exactly.
Okay.
It's all about matching the action to the platform.
Okay.
But there's another crucial piece we haven't talked about yet. Memory.
Yes.
Yeah.
We've covered environment, constructions, planning action.
Yeah.
But why is memory so important for these agents?
Well, imagine trying to book that flight we talked about.
Yeah.
Without remembering any of the previous steps.
Right.
It would be chaos.
You'd be constantly starting over, getting lost in the menus. It'd be a nightmare.
Precisely.
Oh my gosh.
LLM-brained agents need memory to keep track of where they are in a task, the decisions they've made, and the information they've gathered along the way.
So are we talking about the same kind of memory that LLMs have, like that context window that limits how much they can remember?
That's part of it.
Okay.
But GI agents actually have two types of memory.
Okay.
Short-term and long-term.
Okay, so short-term memory is like our working memory, right?
Exactly.
Holding on to information just long enough to use it.
Yeah.
Like a phone number you're about to dial.
Exactly.
Okay.
It tracks the immediate context of the task, but just like our own short-term memory, it has limits.
So how do agents deal with that?
Right.
Do they just forget everything after a while?
That's where clever memory management comes in.
Okay.
Think of it like tidying up your desk. You keep the most important things close at hand and put the rest away for later.
Okay.
Agents do something similar.
Gotcha.
Making the most of their limited short-term memory.
Fascinating. So what about long-term memory? Is that where the agent stores things it needs to access over longer periods?
Precisely. It's like the agent's knowledge base.
Okay.
It stores successful task strategies, guidelines for how to operate, and even patterns it's learned from past experiences.
It's like learning how to ride a bike.
Yeah.
Once you've got it, you don't forget.
Right.
Even if you haven't done it in years.
Exactly.
Okay.
Whole long-term memory lets the agent build on its successes and avoid repeating mistakes.
Yeah.
It's a key part of how these agents learn and evolve over time.
So it's not just about remembering specific actions, but about developing a deeper understanding of how to interact with the digital world.
It is.
It's like building a kind of digital intuition.
You've got it.
Wow.
And that intuition is only going to get stronger as these agents continue to learn and adapt.
This is all really incredible.
Yeah.
We've covered the basics of how these LLM-brained agents work, but I'm curious about what's next on the horizon.
Sure.
What are some of the cutting-edge techniques and innovations that are pushing this technology even further?
Well, one area that's really exploding is the use of computer vision for GUI parsing.
GUI parsing, what's that all about?
Think about how easily you recognize buttons, icons, and text fields.
Yeah.
You don't need labels to understand what they are or how to use them.
Yeah,
It's just intuitive.
Intuitive.
And researchers are using techniques like object detection and character recognition to teach AI that same intuition.
So instead of relying on code or metadata, the agent can actually understand the interface just by looking at it.
Precisely.
Wow.
This opens up some really exciting possibilities.
Like what?
Imagine agents that can interact with any software.
Oh, wow.
Even if it's brand new.
Okay.
Simply by understanding the visual cues.
That would be huge for accessibility.
Absolutely.
People with disabilities could use any software just by describing what they want to do.
Exactly.
No more fiddling with complex menus.
This tech has the power to make technology truly inclusive.
That's awesome.
But there's another innovation that's equally fascinating. Multi-agent frameworks.
Multi-agent frameworks. Does that mean multiple AIs working together?
Yes.
Like a team of digital specialists?
You got it.
Cool.
Imagine one agent that's a whiz at web search.
Okay.
another that excels at summarizing documents, and another that's a pro at scheduling.
Wow.
Working together. Yeah. They could accomplish far more than any single agent on its own.
So instead of one generalist AI, we're moving towards specialized agents that collaborate.
Yes.
It's kind of how we work in the real world, right?
Exactly. It's a more efficient and powerful approach.
Okay.
But hold on, because it gets even more futuristic.
Okay, alrighty.
Researchers are also exploring how to enable agents to evolve over time.
Evolve? You mean they actually learn and improve on their own?
Precisely.
Wow.
Imagine an agent that can refine its skills, discover new tools and techniques, and even adapt to unexpected situations without needing explicit programming.
Wow, that's incredible.
It is.
So they're constantly learning and growing.
Yes.
Becoming more capable with each experience.
They are.
It's almost like they're developing a mind of their own.
It's a fascinating area of research.
Yeah.
But it also raises some important questions about control and safety, which we'll get to later.
Okay.
For now, let's talk about how these agents actually learn from their experiences.
Okay, so is it all trial and error? Oh. Or is there something more sophisticated going on?
There's a powerful technique called reinforcement learning.
Okay.
That's key here.
All right.
It's based on a very simple idea.
Okay.
Think about how children learn. They try things, make mistakes, and get feedback from the world around them.
Like learning to ride a bike?
Exactly.
You fall a few times,
but
eventually you figure out how to balance and steer.
Reinforcement learning works the same way.
Okay.
We give the agent a goal, let it experiment in a safe environment, and provide rewards for successful actions.
Gotcha.
It's like training a digital puppy.
That makes sense.
Yeah.
So the agent learns by doing just like we do.
Exactly.
It figures out what works and what doesn't through experience.
Precisely. And through reinforcement learning, these agents can discover strategies that even human programmers might not have thought of.
Wow, that's cool.
But all this learning requires a lot of data.
That's right.
Yes.
We've talked about how these agents need tons of data to train and evolve.
Right.
But where does all that data come from?
That's a crucial question.
Yeah.
We need high-quality data that accurately reflects the diversity of real-world interfaces and tasks.
Yeah.
Imagine trying to teach an agent to book a flight using only data from a weather app.
That wouldn't work very well.
Not at all.
Okay.
So researchers have been hard at work creating specialized data sets for training these agents.
So what do these data sets look like?
They include things like screenshots of different interfaces, recordings of how users interact with those interfaces, and even annotations that explain what's happening at each step.
It's like creating a giant library of digital experiences for the AI to learn from.
Exactly. And there are already some impressive data sets out there.
Like what?
For web agents, there's Mind2Web, which focuses on web browsing tasks. And for mobile agents, there's AITW, Android in the Wild, which captures the complexities of smartphone use.
It's amazing to think that all this data is being used to train AI that can understand and interact with our digital world.
It is.
But all this technical talk makes me curious about how this technology is actually being used right now.
Okay.
What are some of the real-world applications that are already making a difference?
Well, one area where these agents are having a huge impact is GUI testing.
GUI testing?
Yeah.
That sounds like something developers do.
It is.
How are LLM-brained agents involved?
Traditionally, testing software was a very manual process.
Okay.
Someone had to click through every possible scenario.
Yeah.
Which is time-consuming and prone to human error.
And that's where these agents come in, right?
Exactly.
They can automate the testing process.
Yes.
Making it faster and more efficient.
LLM-powered agents can execute test cases, generate test data, and even find bugs automatically.
Oh, wow.
They can explore far more scenarios than a human tester ever could.
Right.
And they do it without getting tired or making mistakes.
So they're not just automating the boring parts of testing.
Right.
They're actually making the process smarter.
Yeah.
That's got to be a win for developers and users alike.
Absolutely.
Cool.
And research has shown that these agents can achieve better test coverage than traditional methods, which means fewer bugs slipping through the cracks.
That's definitely a good thing.
It is.
So GUI testing is one area.
Right.
What about virtual assistants? I can see how LLM-brained agents could take those to the next level.
You're absolutely right. Think about the virtual assistants we have today. They can set alarms, play music, and answer simple questions.
Right.
But they're still quite limited in what they can do.
Right. They can't really interact with complex software or understand our needs in a deeper way.
Exactly.
Okay.
But these new agents are changing that.
Okay, cool.
They can handle much more complex tasks, automate entire workflows, and even provide personalized help based on our individual preferences.
So it's not just about asking Siri to play a song anymore. It's about having an AI assistant that can actually help you get things done.
Precisely.
In your digital world.
Imagine an assistant that can book your travel, manage your finances, or even automate tasks at work, all while learning and adapting to your specific needs.
That would free up so much time and mental energy.
It would.
It's like having a personal digital butler.
That's a great way to put it. And we're already seeing some really promising research in this area. For example, there's ProAgent, which is designed to automate complex business processes. And visibility, which makes data visualizations accessible to people who are blind.
So it's not just about convenience.
Right.
It's about making technology more inclusive and powerful.
It is.
For everyone.
Exactly.
That's great.
And the applications go far beyond GUI testing and virtual assistants. Researchers are exploring the potential of LLM-brained agents in areas like gaming education and even healthcare.
Wow. It sounds like this technology has the potential to touch almost every aspect of our life.
It truly does.
Wow.
But as with any powerful technology, there are also challenges and risks that we need to consider carefully.
That's a good point.
Yeah.
It's easy to get caught up in the excitement of all these advancements. But it's important to think about the potential downsides as well.
Absolutely.
Okay.
We need to be mindful of things like security, reliability, and the potential for unintended consequences.
So let's dive into some of those challenges. What are the things that researchers and developers are grappling with as they build and deploy these agents?
One of the biggest challenges is ensuring that these agents are robust and reliable.
What do you mean by that?
Well, we're talking about AI systems that are interacting with complex software. Any errors or unexpected behavior could have serious consequences. Imagine an agent that accidentally deletes important files or makes an unauthorized purchase.
That would be a nightmare. So how do we prevent that from happening?
It requires a multifaceted approach.
Okay.
Researchers are developing rigorous testing methods, building in error handling mechanisms, and even exploring ways to provide human oversight for critical tasks.
So it's not just about letting the AI run wild. It's about creating safeguards and controls to make sure these agents operate safely and predictably.
Exactly.
Okay.
And another challenge is dealing with the sheer complexity of the digital world. We're talking about millions of apps, websites, and operating systems, each with its own unique interface and quirks.
It's like trying to teach an AI to navigate a labyrinth. With endless hallways and shifting walls.
That's a great analogy.
It does feel that way.
And that's why researchers are exploring new techniques for making these agents more adaptable and resilient.
Yeah, that makes sense.
They need to be able to handle unexpected changes, learn from their mistakes, and even generalize their knowledge to new and unseen situations.
It sounds like a tall order.
It is.
Wow.
But the progress being made is truly remarkable.
That's good.
And another challenge that's closely related to complexity is the issue of latency.
Latency. You mean delays in processing or response time?
Exactly. LMs are powerful, but they can be computationally expensive. This means that actions might not always be instantaneous, especially on devices with limited processing power.
I can see how that would be frustrating for users.
It would.
Imagine waiting several seconds for an agent to respond to a simple command.
It's definitely a hurdle
that
researchers are working to overcome.
Like how?
They're exploring ways to optimize these models, compress their size, and even leverage specialized hardware to speed things up.
It sounds like there's a lot of work being done.
There is.
To make these agents faster and more efficient. But what about the user experience? How do we make sure that interacting with these agents is intuitive and enjoyable?
That's a great question.
Yeah.
And it brings us to the fascinating challenge of human-agent interaction.
What are some of the key considerations in this area?
Well, first and foremost, we need to think about how humans communicate their goals and intentions to these agents.
Right, yeah.
We're so used to communicating with each other using a rich mix of language gestures and expression.
Yeah.
Like pointing at something on a screen and saying, I want to buy this.
Right, like pointing at something and saying, can you make this bigger? Or I don't like this, show me something else.
Exactly.
Okay.
So we need to design interfaces that allow for that same natural and intuitive way of interacting with AI agents.
It's not just about giving commands, it's about creating a more natural and collaborative experience.
Precisely.
Oh, okay, cool.
And another important aspect is providing feedback to the agent. We need to let it know when it's doing something right.
Right.
When it's made a mistake.
Yeah.
And how it can improve.
It's like training a puppy.
That's a great analogy.
You need to be patient, consistent, and provide positive reinforcement.
And just like with a puppy, building trust is crucial.
Yeah.
Users need to feel confident that these agents are acting in their best interests and that they can intervene or correct the agent if something goes wrong.
So transparency and control are key.
They are.
Users need to understand how these agents work and feel like they have a say in how they're used.
Absolutely.
Okay.
And that brings up another crucial challenge.
What's that?
Security and privacy.
Okay.
These agents often need access to sensitive information in order to perform their tasks.
Right, like personal data, financial details, or even access to our devices and accounts.
Exactly.
Yeah.
So we need to develop robust security measures.
And privacy-preserving techniques to ensure that this information is protected and used responsibly.
It's a big responsibility.
It is.
But it's essential if we want people to trust and embrace this technology.
I completely agree.
Okay.
And it's not just about the technical aspects of security and privacy. We also need to consider the ethical implications of these powerful AI systems.
That's an important point.
Yeah.
As these agents become more sophisticated, they raise all sorts of questions about autonomy, responsibility, and the potential impact on society as a whole.
Exactly.
Wow.
We need to have a broader conversation about the values and principles that will guide the development and use of this technology.
It's a conversation that needs to involve everyone.
It does.
Not just the technologists and policymakers.
It's true.
We all have a stake in shaping the future of AI.
I couldn't agree more.
Okay.
And as we move forward,
it's essential that we approach this technology with both a sense of wonder and a healthy dose of caution.
That's a great way to put it.
Yeah.
Wonder at the incredible possibilities, but also caution to ensure that we use this power wisely and responsibly.
Exactly.
Okay.
And with that in mind, let's shift gears a bit and delve into something fundamental to these agents, their architecture.
Okay, so we're going under the hood now.
Yes, we are.
It's like looking at the engine of a car.
It is.
We know it can drive.
Yeah.
But how do all those parts work together to make it happen? Okay, so going under the hood now.
Yes, we are.
It's like looking at the engine of a car.
It is.
We know it can drive, but how do all those parts work together to make it happen?
It's a complex system, but we can break it down into manageable chunks.
All right.
And while the specifics can vary depending on the agent, there's a general blueprint they tend to follow.
Perfect. Lay it on me.
First, we've got the operating environment, which we've talked about quite a bit already.
All right.
This defines the agent's world. Is it operating on a website, a mobile app, or a desktop environment?
Right. And that determines the rules of the game, so to speak.
Exactly.
What tools are available, how the interface is structured, all that.
The agent needs to be fluent in the language of that specific environment.
Okay.
Then we have environment perception.
Okay.
This is how the agent gathers information about its surroundings.
So it's like the agent's senses,
You got it.
how it sees and understands what's happening on the screen.
Agents typically use a combination of techniques, like taking screenshots, analyzing the layout of the interface, and even reading the text on buttons and menus.
Right.
It's like giving the AI a set of digital eyes.
That makes sense. So it knows where it is.
Right.
And can perceive the environment.
Yeah.
What happens next?
This is where prompt engineering comes into play.
Okay.
Remember, We need to give the agent clear instructions in a language it can understand.
Right, like giving someone detailed directions.
Exactly.
The more specific and clear the instructions, the better the outcome.
A well-crafted prompt tells the agent what needs to be done, any constraints it needs to consider, and sometimes even includes examples to learn from.
So the prompt is like the blueprint for the task.
You could say that.
Okay.
Now, once the agent has its instructions, the real thinking begins.
Okay.
This is what we call model inference.
So the agent is taking the prompt and all the information it's gathered about the environment and starting to formulate a plan.
Precisely.
Okay.
It's like the AI is strategizing, breaking the task down into smaller steps, figuring out the best actions to take.
Okay.
And even anticipating potential challenges.
It sounds almost like the AI is playing a game of chess.
That's a great analogy.
Thinking several moves ahead.
And this is where the power of the LLM really shines. It's not just following pre-programmed rules.
Right.
It's actually reasoning about the best way to achieve the goal.
Impressive. Okay, so the plan is set.
Right.
What happens next?
Now it's time for action execution.
Okay.
This is where the agent translates those high-level plans into concrete actions within the digital environment.
So things like clicking buttons, typing text, navigating menus, all of that.
The agent has to be fluent in the language of the specific platform it's operating on, using the right tools for the job.
Right. It needs to know how to use a controller if it's playing a game. Or keyboard shortcuts if it's in a word processor.
Precisely.
Okay.
And throughout all of this, the agent relies on its memory.
Yes, memory. We talked about short-term memory for immediate tasks and long-term memory for storing learned knowledge and strategies.
Exactly. Both types of memory are crucial for the agent to function effectively.
Makes sense.
It's like having a mental workspace for juggling current information and a library for storing valuable lessons.
This architecture is fascinating.
Yeah, it is.
It really highlights the complexity of what these agents are doing. But I'm also thinking about the future.
Sure.
What are the big unanswered questions that researchers are still grappling with?
Well, one area that's particularly exciting is the quest for truly general-purpose GUI agents.
Okay.
Right now, most agents are designed for specific tasks or domains.
Like playing a game, booking a flight.
Exactly, or testing software.
Well, what if we could create an agent that could handle any GUI task, regardless of the software or platform?
That would be amazing.
It would.
Like having a universal digital assistant that could learn and adapt to anything you threw at it.
It's a challenging goal.
Yeah. But the potential is enormous.
It would require an AI that can understand the underlying principles of GUI design and human-computer interaction, not just specific instances.
It's like teaching the AI to think like a user, to anticipate needs and adapt to different contexts.
That's incredible.
It's a tall order.
Yeah.
But researchers are making progress.
It's good to hear.
They're developing new training methods, creating more diverse data sets, and exploring ways to make these agents more flexible and robust.
It's exciting to think about where this research could lead.
It is.
What other frontiers are you excited about?
Another area that's ripe for innovation is human-agent collaboration.
Okay.
We've touched on it before, but there's so much more to explore.
I'm all ears. What are some of the key challenges, opportunities you see in this space?
Well, one of the biggest challenges is designing interfaces that allow for truly seamless and intuitive interaction between humans and AI agents.
Okay.
We're so used to communicating with each other using a rich mix of language gestures and expressions.
Right, like pointing at something and saying, can you make this bigger? Or I don't like this, show me something else.
Exactly.
Okay.
So we need to develop ways for users to communicate naturally with AI agents, to provide feedback, correct errors, and even teach the agent new skills.
It's like having a conversation.
Precise.
A true back and forth where both the human and the AI can learn and grow together.
And it's not just about communication.
Okay.
It's about building a relationship of trust and understanding.
Right.
Users need to feel confident that the agent is working with them, not against them.
So transparency is key.
It is.
Users need to understand how the agent is making decisions and be able to intervene if something goes wrong.
Absolutely.
Gotcha.
It's about finding the right balance between autonomy and control, allowing the AI to be helpful and efficient while ensuring that humans remain in the driver's seat.
That's a great way to put it.
Yeah.
And this all ties back to those ethical considerations we talked about earlier, right?
It does.
Making sure that these powerful AI systems are aligned with our values and used for good.
Exactly. We need to have those difficult conversations about responsible AI development, data privacy, and the potential impact on society as a whole.
It's not just about the technology itself, but about how we use it and the kind of future we're building together.
Couldn't agree more.
Yeah.
And I think that's a perfect note to end our deep dive on.
It's been a fascinating journey.
It has.
We've gone from the basics of how these agents work to the cutting edge of research and the big questions about the future.
It's a field that's constantly evolving.
Yeah.
And it's incredible to see how far we've come in such a short time.
And who knows what the future holds, but one thing's for sure. LLM-brained GUI agents are poised to have a profound impact on how we live, work, and interact with the digital world.
I completely agree.
Wow.
And I encourage everyone to keep learning, to stay curious, and to engage in those important conversations about the future of AI.
Because ultimately, the future is up to us.
It is.
Let's make it a good one.